This, this presentation will cover plant propagation. Again, this is Jim Robbins with the Cooperative Extension Service. Before beginning, let's go over a few helpful resources. The first is considered the textbook for plant propagation. The original book, authored by two individuals, Hudson Hartman and Dale Kester, is now in its 8th edition with a 9th edition under development. This book, while expensive, is considered the most complete resource on all aspects of plant propagation. An excellent and affordable resource for woody plant propagation is the Reference Manual of Woody Plant Propagation. Again, this resource is focused only on woody plants. The Cooperative Extension Service has some great free resources. The first is a fact sheet, FSA 6024, Plant Propagation for Home Gardeners. Still available is a great fact sheet, FSA 2095, which is focused solely on propagating houseplants. And a fact sheet focused solely on rooting azaleas, FSA 2092. Plant propagation is as much an art as it is a science. This image was taken from the cover of a nursery trade publication and nicely captures the essence of all aspects of propagation. So let's start up in the upper left-hand corner, and we've got cutting, examples of cuttings coming down in a counterclockwise fashion, cuttings, seed, another example of seed, maple seed, tissue culture, budding, grafting, rooting hormone, and finally an example of a budding or grafting knife. To begin with, we need to illustrate why plant propagation is so critical in horticulture. So let's start with a fairly uncommon woody plant, the hardy orange or trifoliate orange. The plant has wicked green thorns and what looks like a small mandarin orange-like fruit. There is a specific cultivar called Flying Dragon that has uniquely twisted branches. The question is, if I have Flying Dragon and I want to share this unique plant with my fellow gardeners, will the specific selection or cultivar with these twisted stems come true from seed? The answer is yes. If you sow the seed from this cultivar, nearly 100% of the seedlings will be similar to the parent. So maybe all we need to know is seed propagation. Well, let's consider then another horticultural example. Let's say you have white county peach in your backyard and you would like to propagate the tree to share with fellow gardeners. If I collect and sow seed from my white county peach tree, will the offspring be the same? Positively no. Now, the seedlings will be some kind of peach, but they will not be the same delicious variety, white county. This selection does not come true from seed. To ensure that we get the peach variety that we want, we propagate this tree using a vegetative means of propagation, in this case, budding. And our final example, let's say you have a lovely Crimson Queen Japanese maple in your yard that you want to share with fellow gardeners. We ask the question again, if I sow seed from this plant, will the progeny be the same as Crimson Queen? The answer again is no. The seedlings that develop will be Japanese maples, but they will not be the beautiful weeping cutleaf purple leaf variety that you so love. So since this cultivar does not come true from seed, we again need to use a vegetative means of propagation. And in this case, we will use grafting. The reason for giving these examples is to emphasize that the majority of cases with horticultural selections, the plant variety we so desire, does not come true from seed. So we need to use alternative means of propagation to pass these unique traits on to the next generation. This point is so germane to our understanding that we will highlight one more example. In Arkansas, we have a native shrub called the smooth hydrangea, Hydrangea arborescens. The flat-topped inflorescence on the wild type is only somewhat showy. However, back in the early 1900s, a gardener in Anna, Illinois, noticed a form or variant of our native shrub that had exceptionally large flowers. And I think between the two upper images, you can see the difference. There clearly is a strong benefit in the cultivar on the right. If we collected seed from this unusual form, none of the seedlings would display this larger and more showy flower type. To duplicate this unique form, we again need to use a vegetative means of propagation, and in this case, stem cuttings. The point is clear that in horticulture, where we are most interested in plants with better tasting fruits, different colored flowers, larger fruits or flowers, etc., we need to use vegetative propagation techniques. Now that we have established why vegetative propagation methods are so critical in horticulture, we need to start our discussion about plant propagation. To begin with, we can divide plant propagation methods into two broad categories: vegetative or asexual methods, and second category, sexual. From this list, it is apparent that most of our plant propagation methods fall under the first category, vegetative. This would include cuttings, grafting, budding, layering, division, and tissue culture. While this presentation will cover all of these plant propagation methods, the majority of our time will be spent on cutting propagation, since that is something that most home gardeners can be very successful at, and due to time constraints. Before we get started, we need to go over some terminology related to cutting propagation. First, we will use terms to describe where the cutting was taken from. Thus, if the cutting was taken using a leaf, it is referred to as a leaf cutting, from a stem, stem cutting, etc. So now let's look at some examples. Here are some photographs of some plants that are easily propagated using cuttings taken from parts of leaves. Take a moment. Can you identify some of these plants? Houseplants such as peperomia in the upper left, sansevieria or mother-in-law's tongue in the center, African violet in the upper right, and begonias are all easily propagated using leaf cuttings. If the source of your cutting was from a stem, it is referred to as a stem cutting. In a moment, we will go through stem cutting propagation in detail, since it is so commonly used. And the final form is root cuttings. Root cuttings are rarely used, but it is a source of cuttings for a few plants. Continuing on our foundational discussions of cutting terminology, there are specific terms we use when propagating plants by stem cuttings, and these three terms refer to the type or age of stem wood being used. Thus, we have terms such as softwood stem cuttings, semi-hardwood stem cuttings, and hardwood stem cuttings. These three terms are used to describe the relative amount of woody tissue in a stem. For softwood stem cuttings, think of many of the shrubs in your yard when in early spring, you get that first flush of growth. Notice the photograph on the right where it easily bends. The tissue is soft and flexible. Softwood cuttings generally root easily, but they may wilt easily. It is worth interjecting that the term herbaceous stem cuttings is more appropriately used when we're talking about non-woody plants, such as coleus. And so I'm sure many of you have tried to root begonias, coleus, etc., just in water. And those are herbaceous cuttings. Returning to woody stem cuttings, the term semi-hardwood represents the transition period for a woody stem. For most of us wanting to propagate woody shrubs in our yard, this is the most likely type of cutting you will use. Therefore, in a few moments, we will go through a series of photographs to discuss this in more detail. This photograph is an example of a semi-hardwood stem cutting taken from a viburnum shrub in July, late July in Portland, Oregon. And these are impressive rooting results 1 month later. The reason for showing this illustration is to demonstrate that when conditions are optimal, the results can be quick and impressive. Now, if we were to duplicate this here in Arkansas, we would have started earlier, back in probably late May or early June. But Portland is cooler, and so their growth is delayed relative to Arkansas. On the other hand, let's look at another woody plant example, in this case, our native juniper. So this cutting was taken, was in a rooting bed for nearly 10 months, and this is the best result that we could achieve. The point, results will vary depending on the plant and your rooting conditions. To complete our discussion on types of stem cuttings, we will conclude with the category of hardwood stem cuttings. While we don't use this type of wood often, when appropriate, it gives great results. Here's an example of a hardwood cutting taken from wild grape in the middle of winter. Each of these stem cuttings was about 8 inches long. By the way, this photograph also illustrates an example that we'll bring up later about how do you know whether your rooting results are successful when these roots are growing along below the substrate. And in general, in my experience over the years, when you have successful rooting, the stem begins to grow. So look at the cutting on the far left, and the stem is flushed very well. The two on the right have less top growth, and their rooting performance is equally poor. So there's generally a correlation to the amount of top growth to what's going on below in the substrate. Here's another example of hybrid poplar. On the right, you can see the original hardwood cutting, which is very long and was buried in the field in late winter. They were laid down in a trench, very much like you would lay cigars, catalpa pods. The photograph on the left shows the amount of stem growth that was achieved later in the season, which is absolutely amazing. You can barely see an individual standing, so these plants are at least 10 to 12 feet tall in a single season. So by now you may ask, well, how do I know what method of plant propagation is best for my plant? Appreciate that people have been propagating plants for a very long time. So fortunately, many of these techniques are well documented and help us get a leg up on the process. There are many, many resources, either online or otherwise, that can help get us pointed in the right direction. And I'll just refer to these as recipes. So it's very similar to cooking. Continuing on our discussion solely about cuttings, we need to discuss some other basic issues, such as when should I take stem cuttings? In general, for broadleaf woody plants such as forsythia, hydrangeas, spirea, weigela, the best time is in late spring. And in Arkansas, this window of opportunity is generally between May 15th and June 15th. For needle evergreen plants, in general, the best time is late fall or early winter. What about a recommendation on the best rooting media? If you look at a textbook, they will say the substrate needs to be sterile, well-drained, and provide good aeration. That's not a lot of help. The most common rooting substrates that we would use would be sand, coarse perlite, coarse vermiculite, and peat moss. Examples of my favorite media for rooting are the following: equal volumes of coarse perlite and peat moss, equal volumes of coarse perlite and coarse vermiculite, pure coarse perlite, or straight sterilized coarse sand. In my experience, a great substrate to start with is 1 part coarse perlite and 1 part peat moss. And you can see what the resultant looks like in the bottom image. The next series of slides is designed to demonstrate just how critical the substrate choice has on rooting results. In this example, its Chinese holly was rooted in 3 different substrates. Without being concerned with a specific substrate, notice the dramatic effect that our substrate choice has on our rooting results. Notice on the far left that Chinese holly did not root very well under these conditions in peat moss, but rooting was much better, much improved in vermiculite and perlite. Here are 2 other plants that we rooted in 4 different substrates. Again, without being concerned about what the plant is or the substrate, it is clear that the impact of the substrate choice on rooting results. The point of these examples is to emphasize that if your initial rooting results were disappointing, next time simply try a different rooting substrate. Some of these recipes that we referred to earlier for rooting cuttings will mention using a rooting hormone. A variety of products are available to the home gardener. Next, we need to quickly go over the impact of different environmental conditions, moisture, temperature, and light on rooting results. Let's start with moisture. As we will discuss with temperature, we will separate our comments into the environment above the rooting substrate and moisture in the rooting substrate itself. We make this distinction since it is important to emphasize that what is required is different depending on cutting tissue above or in the substrate. Let's start by commenting on moisture requirements for the stem cutting tissue above the substrate. It makes sense to think that since we have removed this stem from the parent plant, it no longer can replace water lost. So we want to do everything possible to keep the atmosphere surrounding the aerial portion of this cutting as close to 100% as possible. The easiest way to achieve this for home propagation is simply to trap the moisture already present in the rooting substrate, and we will demonstrate some simple methods shortly. For moisture requirements in the substrate, we want the substrate to be moist, but not too dry or too wet. What about the ideal temperature requirements for rooting stem cuttings? Ideally, we would like the portion of the stem above the rooting substrate to be cool to minimize stress, while the stem portion inserted in the rooting media being slightly warmer to help promote cell division. If you had full control over the situation, these would be ideal temperatures for many stem cuttings. So the air 55 to 65 cooler than the substrate temperature. Light is the third environmental parameter that we need to discuss. Keep in mind that we have removed this stem from the parent plant, so the cutting is under tremendous stress until it forms a new root system. Thus, a low light level is required to simply maintain the stem. Keeping your unrooted cuttings in a south-facing window would not be recommended. And notice in the photograph, what we did was in the rooting tray, we simply inverted another tray, a seedling tray, that has these slats in it, so it provides like 50% shade. Kind of a neat little trick. Remember that until the stem forms new roots, it cannot replace water lost through leaves or stems. Environmental conditions that reduce plant stress will favor the rooting process. For home gardeners, there are lots of very simple ways to elevate humidity around cuttings. All of these methods rely on simply trapping the moisture that is already present in the rooting substrate. In any of these approaches, if you observe excess condensation, you can simply vent the vessel and then reseal. So let's start up in the upper left. This is used by a master gardener in Clarksville, and simply took some clear soda bottles, cut them in half. This works well for one bottle section per cutting, so there's usually only a single cutting under that. My preference for this is I love the tops of the bottles, because then what you can do is, again, if you see excess moisture, you can simply unscrew the cap, allow some of the moisture to ventilate off, and then you can reseal it. So that's a really nice, simple method. In the bottom left is an example from a Master Gardener Advanced Propagation class, where we simply cut up some cell packs for bedding plants, went to the produce section of a grocery store and got some of these clear clamshells. And this is a really ideal, little simple, inexpensive system for a homeowner. If you want to do more cuttings in the center, just take a seedling tray, some metal strapping, and a bag, a clear bag. Upper right is a commercial unit that's for sale. And notice that it offers these two vents. So again, if you see too much condensation or moisture accumulating, you can vent. And then the bottom right is the simplest, just a large Ziploc bag. Works really well for a simple rooting of cuttings. Now we've gone over the basics of rooting stem cuttings. Let's quickly go over a series of slides to walk you through the process step by step. And for this example, we will be taking terminal stem cuttings from big leaf hydrangea. First step is to remove the cutting from the plant using hand pruners. Recalling our earlier discussion about reducing stress, for many cuttings, we will reduce the leaf surface area by trimming leaves. Once we have trimmed leaves, we are left with this stem cutting. Since the literature will often reference the term node, we need to define what that term means. A node is the point on the stem where leaves are attached. So in this photograph, we see at least 3 distinct nodes. So the literature might say, describe this as a terminal 3-node cutting, 5 inches long. Assuming the resource indicates the cutting needs to be dipped in a rooting hormone, in this example, we dip the basal 3/4 to 1 inch in the rooting hormone. The final step is to carefully insert our cutting into the rooting substrate. Depending on the substrate and the strength of the stem, we may need to preform a hole in the substrate before inserting the cutting in the substrate. And oftentimes just using a pencil or a very thin wood dowel will serve to help preform that hole. And finally, we place our cuttings in a rooting structure that will trap the moisture and elevate the humidity around these leafy cuttings. That completes our discussion on rooting stem cuttings. Now we will quickly highlight other forms of propagation, starting with air layering. Air layering is basically similar to what we just discussed. However, in this case, we root the stem while it is still attached to the parent plant. Air layering is very commonly used for a number of common indoor houseplants. Grafting is also a means of clonal or vegetative propagation. This photograph is from an almond orchard in a walnut orchard in Central California. And because of the distinctive difference in bark, you can see the darker bark of the black walnut understock very visible here in the bottom of the image, and the English walnut, which is grafted on the top, and that's the desirable crop that we're after. The stem segment that we graft on the top is referred to as the scion. Although we do not have time to go in depth about grafting or budding techniques, you would be surprised how many of the plants in your landscape have been propagated using these vegetative means. Here's an example of a weeping ornamental cherry, and the photograph on the right shows the graft union, which is several feet above the ground. So in the bottom, we have the rootstock, and then the top portion is the weeping, what we call scion. This Crimson Queen Japanese maple was propagated by grafting this unique selection on the rootstock of seedling Japanese maples. And again, on the right, you can see the graft union is somewhat visible. If you have ever purchased or planted a 3-in-1 fruit tree in your yard, that was most likely propagated using top grafting. People always ask, well, why was this plant propagated by the more expensive methods of grafting or budding? And the answer is that the plant likely does not come true from seed, as we discussed early in this section, and the cutting method is not overly successful. But there are specific reasons for grafting that may need to be used, such as size control or greater resistance to environmental requirements. Generally, most homeowners are very successful with seed or cutting propagation, but budding and grafting is a very specialized technique that requires more skill. In the following slides, we will quickly go over general steps of grafting and budding. Remember, with grafting and budding, we are merging two plants together. In the case of grafting, it is a stem section, and with budding, it is the individual bud. On the left side, we have our seedling understock, and on the right, scion wood from our desired selection. There are many types of grafting techniques, but for this demonstration, we will use side veneer grafting, and this is on a selection of our native black gum, Nyssa sylvatica. To prepare the understock on the left, we make a notch in the stem. For the scion on the right, which is a small section of stem, we use the same sharp knife and shape a wedge tip. So on the left, look in the bottom image and you can notice the little wedge-shaped pocket that we've made. Once the two halves are prepared, we insert the scion stem piece into the notched pocket in the understock. Notice how both are approximately the same diameter. The final step is to support this graft union until cell division stitches them together. We also wrap the union in materials that prevent the union from drying out. So on the bottom right, it's actually called grafting wax, and they're dipping it, again, just some materials to help the stem wood from drying out. These images simply show the finished product. What is not shown is that once the graft union takes, we make a cut above the graft union to remove the remainder of the understock stem. Budding is nearly identical to grafting. However, instead of using the entire stem section, we simply harvest the buds, which allows the potential to get more offspring from the same amount of stem wood. The following is a quick series of images summarizing the budding process. In this case, we are field budding a specific dogwood cultivar on the rootstock of seedling dogwoods. This example uses tea budding, but there are other types of budding techniques. So again, we've got our dogwood seedlings in the field on the left, and then these are called bud sticks on the right for some desirable selection. In this case, I just picked white cloud, and we're going to stitch these two together. Appreciate what intricate and hard work this really is. So on the left, notice that the tremendous skill in making, using a very sharp budding knife, a T-notch in this stem, and on the right, we're harvesting a single bud. Very intricate, intricate work. And by the way, it's good to emphasize that in this example, this would be dogwood budding that would go on in central Tennessee only during about 2 weeks in the middle of August. So there's a specific window, ideal window at which this goes on. So it's very, very intricate and skilled work. Step number 3, once a single bud has been extracted, it is inserted in the stem of the seedling rootstock. So you can see, again, just how challenging this would be to do this thousands of times per day. Similar to grafting, in the final step, we wrap the bud to hold the two pieces together and to minimize drying out. In this case, we just use what are called bud strips. They're just very expensive rubber bands, basically. Fast forward in time, once the bud union does take, the stem section remaining from the seedling understock is removed. Thus, what we have in this root system from the understock and the shoot from our desired selection. So just imagine that this photograph was fast forwarded a year later, and here's the understock, about 2 inches of that. Then there's a little notch here or a jog in the stem, and this is the desirable plant coming up. So we came back at some point and made a very precise cut here to remove the remainder of the seedling understock. And by the way, this little bud union where you get this little break is often, you can use that to kind of identify if your plant was budded or grafted, because there's oftentimes, particularly when young, a little jog in the stem. Moving on now to other vegetative means of propagation, there is division. If you have ever divided a hosta or iris, you have used this technique. It is obvious that the small plants we get from division are genetically identical to the parent plant. Plant tissue culture is a relatively new technique to grow plant cells, tissues, or organs under sterile conditions on a nutrient culture medium, either agar or liquid system. Although this method is expensive, it offers advantages that exact copies can be made fairly quickly and in very large numbers. Tissue culture is not something that home gardeners would typically attempt to do due to the expense and requirements for sterile conditions. Tissue culture is performed under sterile and controlled conditions. The final method of propagation we will discuss is seed propagation. Seed propagation would be our first choice to propagate plants because it's typically inexpensive and we can generate large numbers quickly. So look in this example, this is oak leaf hydrangea. Took one of the panicles, let it dry, harvested a very large number of seeds, sowed those. 1 week later, we had a miniature forest. And 4 weeks later, we had way more little seedlings than we, have gardening friends. So, it's a method that can, when done properly, can be very successful. We can generate very large numbers quickly. As we mentioned earlier, a majority of our ornamental plants do not come true from seed. So we are forced to use some of the vegetative means we discussed earlier. To illustrate this point, here's a photograph of seedling progeny from seed collected and sown from Crimson Queen Japanese maple. And this is the mix that we got out of this. So we have some green leaf forms, red leaf forms, cut leaf forms, etc. And this is a very common question that we get in extension is, can I harvest the seed from my Japanese maple and get an identical copy of the parent? And generally the answer is no. Similar to cutting propagation, there are many very complete resources to help determine what is the best time to harvest seed, how to clean the seed, sow the seed, and post-germination care. Resources dedicated strictly to seed propagation can be found on the internet or in hard copy. So here's an example of a book that I bought many years ago, very inexpensive, but had lots of recipes for starting seeds or starting plants from seed. Consult these recipe resources for the collection and processing of your specific seed. Similar to our earlier discussions on stem cuttings, there are certain terms that you need to be aware of. The two that will likely come up are scarification and stratification. The first term we need to define is scarification. If you look at the root word, scarify, you will immediately recognize what this term is all about. Seeds from many plants, especially those in the legume family, have a very hard seed coat designed to protect the embryo inside. To speed up the germination process, we need to etch through this physical barrier. Thus, scarification is any process that alters the seed coat to improve germination. For a home gardener, we will use emery cloth or a file to accomplish this task. For large seeds that we can hold easily between our fingers, so on the left is Kentucky coffee tree, a large file works very easily. But for very small seeds, simply rubbing the seeds between two layers of fine sandpaper or emery cloth works very well. Again, the objective is just to slightly etch the surface to break through that hard seed coat. The other term that we need to define is stratification. Let's start by imagining a red oak acorn in the fall. When the seed is ripe, it would be best if it did not germinate, but stayed dormant through the winter until conditions improved. That makes sense, doesn't it? I mean, the seed that is germinating in the fall, if it were to fall and germinate prior to winter, the harshest time of the year, it would not make a great deal of sense. Well, for many seeds, they come with internal signals that keep the seed dormant through these harsh environmental times. To alleviate this dormancy, the seed needs to be exposed to environmental conditions, both moisture and temperature, that alleviate or override this internal control of germination. A typical scenario involves placing seed in a refrigerator for 60 to 90 days. There are lots of variation on this, though. Here's an example of oak seed being placed in a tray of moist peat moss after collection in the fall, and then stored in a refrigerator on the right for 60 to 90 days. This artificial chilling releases the seed from dormancy so we can germinate the seed more quickly and under our terms. When sowing small seeds, there are lots of tool options to help. So on the upper left, it's just, you can drop an individual seed using that device, or in the bottom right, it's commonly available in gardening catalogs. And the plates, the white plates, come with a different size notch in the base so that it allows different size seeds to be delivered into your tray or seed rows. If these recipes or instructions indicate lightly covering the seed, this is a handy trick that I've found over the years for covering a seed using a flour sifter and fine vermiculite. It's very hard for us to by hand to apply a very fine layer of sand or vermiculite over seed. So you may want to try this trick. The same chambers that we talked about with cuttings work great to germinate seed. So there's the same type of chamber. It's got these vents to reduce some of the accumulated moisture condensation inside. This is a tall chamber, so this works exceptionally well for cuttings, and it would also work great for seeds. So once they germinate, they've got some room. So these taller domed chambers work very, very well. In summary, with seed germination, consult these many valuable resources for specifics to propagate your type of seed. Hopefully you will have many great propagation success stories to share with your fellow gardeners. And now we're going to show you two videos, one of field budding and the other of bench grafting, just to give you an example commercially of what those two processes look like. Now the field budding, just to give you again, so this is commercial field budding. This happened to be in middle of Tennessee, mid-Tennessee in middle of August. And so you can see thousands and thousands of seedling dogwoods visible here. And what we're going to do is we're then going to harvest individual buds from varieties of ornamental dogwoods that we're interested in, and we're going to bud those on these what are called understocks. And the reason for showing this is just so you can appreciate how difficult, challenging this work is, and then understand why some of these plants may be more expensive, is that there's a lot of hard work that goes into preparing these types of plants.
Field budding of dogwoods is typically done in mid to late August in eastern Tennessee. The first step is to prepare bud sticks. Notice how the worker checks the condition of the wood by bending it. Bud sticks are now ready. Once bud sticks have been prepared, a worker begins the process of tea budding. Notice how the bark slips to form a pocket in which the bud will be inserted.
Okay, and so hopefully from that short video of field tea budding, you can appreciate how difficult this work is. And in fact, probably the workers were slowing down just so we could capture it. So very difficult work, and hopefully you've got a better appreciation. And the final video will be about what's called bench grafting. This is at Monrovia Nursery in California, and it's of our very common southern magnolia, but we're going to graft a known cultivar, probably a teddy bear or something like that, on seedling rootstock. So we'll go through this grafting video. And again, just hopefully so you can appreciate how difficult this grafting and budding work is.
This nursery is side veneer grafting magnolias in December. The process begins by making a cut in the stem of the rootstock. The scion is then inserted into the notch in the stem. The two pieces are wrapped with grafting bands, and then both are wrapped with film tape.
Well, hopefully those two videos will, again, give you some kind of an appreciation of how difficult and challenging grafting and budding is. One thing that wasn't shown was, I think for all of us, wouldn't you need a box of Band-Aids handy if you were going to accomplish that? Because very difficult work using very sharp tools. So again, hope you enjoyed this presentation on plant propagation.